Hello everyone, today we're going to resolve LeetCode daily problem number 2338. Count the number of ideal arrays. It is a hard problem in which we are given two integers, n and maximum value, which are used to describe an ideal array. So, a zero indexes integer array R of length n is considered ideal if the following condition hold. Every array index I is value from 1 to max value. Every array index I is divisible by array I minus 1, so the previous element in the array. And we should return the number of distinct ideal arrays of length n. Since the answer might be very long and large, we return it by modular 10 plus 7, 10 of 9. So we gotta make it that mod will be equal to our 10 to the step of 9 plus 7. And we will need that. So for example, input n equal to max value equal to 5. Then we have output of 10 as the following are the possible ideal arrays. So 1 and 1, 1, 2, 1, 3, 1, 5, 1, and in total it's count to 5. Then if we start with 2, 2, 2, 2, 4, then with 3, 3, 3, with 4, 4, 4, and with 5, 5, 5. So in first we have 5 arrays, in second we have 2 arrays, then we have 3 times by 1 array, 1, 2, 3. And total we count 10 distinct ideal arrays. So it's quite hard to think what is required, so we can listen to story that maybe help us understand it better. So imagine you are building a tower of colorful blocks, one on top of the other. You have n layers to start, and at each layer you can choose any block numbered from 1 to max value. But there is a rule. The number on each block must perfectly divide the number on the block above it, so the tower doesn't wobble. So how many stable towers can you build? First, you will learn that prime makeup of every block size using a block Sieve. So you know which prime piece compose each block. Next, for each prime piece, you decide how many times it can appear in the tower by turning that into a simple combinatorics count. It's like choosing where to place identical Lego bricks among your layers. And finally, you multiply those prime bricks choices together for each starting block and add them up. By mixing a classic sieve, stars in both math, and prime factored chums, you discover the total number of wobbles free tower in just one pass. So, from the description, you get idea that we will use 3 algorithms in 3 steps. So, algorithm that we use will be Sieve of Eratosthenes plus combinatorics, and lastly prime power factorization. So the first step will be Sieve of Eratosthenes. Our main goal is to find primitive divisible values, the smallest, so we avoid manual division each previous number. So the first step will be Sieve for smallest prime divisor. For that we will create new array based on zeros, size of maxValue plus 1. Then we look for prime in range 2, maxValue plus 1. So if mid pay equal prime to 0 for I in range prime value plus 1 step of prime, if mine I equal to 0, then mine I will be assigned to primitive. In this way we will avoid manual division of each integer in our array, as the size is quite big. Now we will move to combinatorics, the second step. So second step, we precompute binomial coefficient of C and plus I minus 1 and I. For that we will start with max power, which will be equal to ing log 2 of max value and plus 1. Then C will be equal array of 1 multiplied by max O plus power plus 1. Now we will look for it for I in range of 1 max power plus 1 and C position I will be assigned comp of n plus I minus 1 of I, and we will measure it by our mode. Now we move the third prime power factorization, the last step, where we will receive our answer. So we factor each I and multiply choices per prime exponent. So our answer will be equal to 0, and we return our answer. Inside, for I in range of 1 max value plus 1, we will start with x in our prod will equal to y and equal to 1. Then while x is bigger than 1, we will look for prime and exponent if equal mind of x and 0. So while x modular by prime equals 0, then x divisible equal to prime and exponential will be increment 1, 1. Next, prod will be equal to prod multiplied by our C exponent array and modulo self-mode. Lastly, answer will be equal answer plus prod modulated by self-mode. And here in 3 steps we resolve this issue by splitting it into segments. So in the first segments we avoid divisible, in the next sample we look for combinatoric value. In the last section we combine them together using prime power factorization. So let's run. Max typo, not maxValue, and let's submit it. And it's pretty efficient. Memory bits 100%. Yep. So thank you for your attention. If you have any question or ideas, feel free, leave them down below. Have a nice day. Bye.